So I'm going to have to turn this down or I'm going to go crazy listening to my own voice. Ah, okay. Let's see. Looks like YouTube got it. Looks like Twitch got it. let's test these. Hello, Twitch. Exclamation mark. Chat's working there. Hello, YouTube. May not like that I'm so close to each other. It's fine. So I think that's it. There we go. YouTube one came in. Wonder why the chat thing's not updating. Yeah, it's okay. Okay, so I think we're ready to begin. So today's gonna be a little rough. This is kind of a new thing. I haven't really got time to explore the different options. Been a little busy, as if anyone knows who actually cares. Some of the streams have been delayed or pushed back or whatever. Hopefully we can get back on course very easily. So today we are going to look at how do we use the Opal Kelly USB-C interface with Litex. This is something I want to get working because be much more effective than JTAG. And we're going to get the example of digging down into Litex code, which I'm excited about. Okay, so a simple goal here today is we're going to do the LED chaser that that is on some boards. We're going to use the bottom bits right here, and we're going to use the top bits inside the can't think right. Do the other LED chaser bits inside the USB interface so we can read it easily. That's kind of like the first test of making sure it works. So, oh, wrong, that's the previous slide. So let's explore this. The first thing we need to do is we need to do these interfaces right here, the OK, AA, UH, HU, UH, UHU interfaces. So to do this, we're going to go to our constraint file that we have right here, and these pins we are going to define. Slew fast. Okay, so let us begin the work. This may be a little bit boring per se, but we'll see how it goes. Let's close everything. Actually, platforms right here. That's where we want. So let's close others. We don't need this that bad. Do I remember how to even make this board? Let's see, I go above. I might have to type history just to see what it looks like. Okay. This is going to be our command we need to do. So we're going to add a new interface here. We have LEDs. Let's go find an LED chaser example real quick. So we're gonna go targets. We're going to grab Nexus video. I know this has LED, so let's go look at the LED chaser. LED chaser, request all LED chaser. So I think I need to find a way to combine. I guess we could do two LED chasers. One here, make sure LEDs work, and then one on the other one. I have LEDs working here, so that's good. Now we're going to do kind of a second LED chaser system. We'll see how that goes. We just say user LED. Oh, why didn't we just? I think we could have done this type of interface. What does the video do in this situation? Digital video. Okay, so they specify all these separately for some reason. Okay, so let's grab this. This will probably be a good example of what we're going to do. Okay, here we go. We're going to call this okHOST. This is going to be the Opal Kelly host USB-C interface. What's that 0 mean? I guess, okay, that's what we're dealing with. Okay, so first let's start with how does the DDR do all these fun signals? Okay, so let's look at our first one, right? So let's go down here. Do okAA, do a package for that one, and LVS CMOS standard. Probably just do that across all of them. So yeah, we're gonna do LVCMOS 18, and let us just go in order from smallest to biggest. So this is going to be okAA, okAA, P19. I have to figure out how to do generics too. I might have to do my own wrapper with specified generics. That's gonna be fun. Okay, what's next? Let's do the host to user. Which is the in user to host. Let's do user to host or USB to host. Nah, we'll do this next. So okay, host to user, and we're gonna have 220, 226, and P22. Okay, and then we're gonna do a few more. It's 5. Say V22. V23. Should we try this in a way that doesn't drive everyone crazy? Okay, everyone can see better now. It's supposed to be like that. We can also, there we go, click it like that. Hopefully everyone can see a little bit better now. That works well. Okay, so T23, U22, U25, U21. Hey, look, we can go faster now. Okay, LVMOS 18, everything is LVMOS slew fast. Everything slew fast. Okay, now comes the fun one. We have okUHU. UHU, and let us write all those out. We'll probably do by 8s. P26, 5, R26, R25, R23, R22, 1, 2, 4, 5, 6. Okay, 2 more, P21 and P20. And I believe we can just go to the next line, right? So end the thing, comma, next line. I think it's fine if we go that. There we go. Do R21. Must be 21. R20, P23, and 23, P5, 25, and 24. And that should be 15 minus 2, that should be 13. That is 13, so we're good, we're on track. It'll be 26, comma. After B26 is N19, B21, N21, W20, W6, W19, 2 more, Y25, and Y26. Here we go. Pretty weird when we get to the double ones, but oh well. Y22, B22, W21, AA23, Y23, AA24, W25, and AA25. Drive strength here. And there we go. We have successfully created the okHOST interface. What's happening down here? Okay, so we have to set up our sources, so let's do that real quick. So we're going to cat okay, cool. We need to grab these two and paste to 2.1. I'll go into Litex. Right, this is what we have. Build folder, yep. And let's go find that beautiful build command that was all the way. Still gotta go further. There we go. So yeah, let's try doing this. We save this, right? So next we're going to, why does it building? We're going to copy the LED one and we're going to make a fun one. Well, first let's go look at our wrapper here, right? So where are these files going? These are going to our top. So let's go look at our top, which is a block diagram apparently. Okay, flow navigator, give me the block diagram of top apparently. Apparently I did this inside a okJTAG probably. So where is, here's an RTL. Oh, here's the bidirectional ones. We didn't really specify the direction. I guess you do that at a level LEDs. Okay, so we're gonna go ahead and pop open okJTAG and look at it. We want to do something like this. So we have the wires, we have a system clock, but I'm pretty sure you generate a clock. So yeah, this clock here. okHOST. OK clock must be an output. OK E. So what we want to do is basically we want to create that single interface. So we might have to create a VHDL wrapper for that. Or what we could do is just do the OK high. Let me look at this guy real quick. Okay, hi. Yeah, we can just do this one. This would probably be the best thing. Um, Interesting to look at the DNA and DNA valid. Um, so yeah, so this is what we're dealing with. This is our interface outwards. This is our interface inwards. And okay, JTAG, so EP. Where is the okay? Okay, it's in the OK library. So we have okHOST. Now where's our module? Where's our EP? I don't know, what are they called? We are looking for OK wire in, I think. LED. Yeah, so we want OK wire in. OK wire in. We attach the HEE to it, and we have an address that's dynamic and a data out. So we want to add that component. What is our what libraries? Looks like we need to add all of these. What files is that? Okay, let me see. Um, that's where the Verilog file is. But what? Okay, so that is a different file. Those are the okay. So we need these Verilog files, and we have more here, and that VHDL file or Verilog file. We can do the Verilog option. I like the VHDL option. We'll probably we may have to do the Verilog option. So Verilog option should be identical. Okay. Doing global routing. So let's go. What we want to go look at is the LED chaser. I also want to look at the SOC gen thing. So in Litex, we're going to we want to look at the SOC cores and go to LED. So we have LED chaser and has the pads, the 6 o'clock ref, and the period. So that's good. And then we can just grab pads equals pads. And then we might be able to explore it a little bit differently. Ooh, NeoPixel in here. That's fun. But back up. Back up. They actually have good documentation. So N is equal to length of pads. And then we have chaser, which is a signal of N. Chaser pads equal chaser. Mode equals control mode. Pads equals self-out storage. Otherwise, we're just chasing. Okay, so we'll have to create this system. I guess we just are going to I don't really think the PMW needs to worry about that per se. But we're going to do this, and we're going to do what we're going to call okay host. Okay, so this will be fun. Okay, so first we need to understand how we add a Verilog module and we connect things to it. So to follow that, the best example I saw was going to be in the Litex SoC generator. We're going to go look at the target. Right here. And so here we add a source. So maybe we should just add sources and see what happens. See if it even builds correctly. And platform. And then we have a special. So this is where we're instantiating the signals. So they created signals up here, right? So they created an interface. We may have to just create signals. And so this is how they connected it. Okay, let us try it. So first, let's just do add source. And LEDs, do we have access to the platform? So if I do self dot add add source, right? And we're going to have to do it from a magical directory. Oops. Star.b. We'll figure that out in a second. Okay, so let's go ahead and add the files. Files over here. If I remember correctly, these files are not the easiest thing to find. They're in the program files under Opal Kelly, the FrontPanel USB. Okay, here we can explore it from here. We can go on this journey together. So you're gonna go FrontPanel HDL. You're going to pick your device. An old one. I don't think it really matters. We're going to take these files. We're going to drag and drop. So these are the only two readable files. The rest of the files are encrypted. It'll be interesting to see if how these are handled. But yeah, let's go try it. Here we have our system. We're gonna make a directory at the top level, call it okHOST. cd into okHOST, and go up here until we get to root directory. You're gonna go okHOST, drag and drop these files. Cool. And now let us add these files. Where was it? Okay, cool. So go ahead and just go down the list. Okay, BT pipe in. So we're gonna do BT pipe. Okay, for harness. Okay, library, which is going to be our main interface. So this is the readable one. Readable file. And we're going to add okay pipe in. pipe out. Okay, register bridge, and okay, trigger in. Okay, trigger out. I think it's funny because okay is like one of the things. Oh, we got a perfect number. It's one of the things I say, just like okay, continuing conversation. So I think it's just saying okay over and over again is really helping me have a flow of conscious. So we did this. So we're going to save the file, and we will rebuild. We'll see. Actually, no, I gotta add it to the target. So we're going to do okHOST chaser. Here in the target, we're going to do okHOST chaser. okHOST chaser instead of the other one. Oh, no, wrong board. We want to go to the Opal. Opal Kelly one in the Litex board repository. So targets Opal Kelly. There we go. Here, right here, this one. We want to do okHOST chaser. Like a drink chaser. Okay. Chaser is not defined. Right here. So we want to say okHOST chaser. Boom. No object. Add source. This is passing the platform in. So I guess we need to pass the platform in. So let's go back here. Oh no, right here. And we need to pass the platform in. Let's just right here make it platform. We need to do anything else in the situation? What other things? The SOC. So let's go look at the SOC here. And how are we passing in platform? So we want to go to the init up here, wherever it may be. So we're just calling platform. And I see nothing else important to add. So, we're just going to say platform. And just do this and see what happens. Get to target. And now we have another parameter. And we're going to do a comma. We're going to say platform flat. Okay. So terribly interesting. Okay, that worked. Error occurred in here. This is where things get fun. Okay. It was running it. Okay, we need to copy those files. So yeah, let's just straight up copy it here. Sounds like a plan, right? Let's we'll do it in the Litex area. So we're gonna say copy recursively. Okay, host one above. So it's ls. Okay. Cool. So now we're gonna go here. No, we're gonna go to LEDs. And see if I can do this efficiently. We're going to do that. Now we're going to rerun our command. See if we can get I should check my Discord to see if anything's happening. Heard anything. Feel free to jump on the stream chat. You won't be recorded or broadcasted or anything. So we have those files, so we're reading those Verilog files, and that's good. That's good. And because this is now, we just need to do an instance of it, and we're gonna do in that situation. We're gonna say okay, and we're gonna try to instance it. Right, yeah. While doing the LED chase and slowly at some point change it. I assume signal is just the length. Everything else, let's go look at the ICAP, right? What's signal 32? Okay, cool. We'll just do signal whatever. So it looks like that's working. So now what we want to do is do something where we can do an equal here as well. So let's try. I think that shouldn't be too hard. We should be able to do this relatively quickly. So go back to that SOC generation one here, and we want to do self.special. Hopefully that works just fine. Go ahead and just copy it perfectly. We'll keep these here. And so let's get the name correct. We're gonna go jump over here, and the name we are looking for is okHOST. So we're going to add a okHOST instance, and I assume these names need to match up perfectly with these names. So we'll just bring these over, right? Okay, so let's see. These are going to be okay pads, and these are going to be internal signals. Ignore the clock for now. Okay. Looks like it creates a new clock signal. That's input clock. Oh no, it's just grabbing a clock signal. But yeah, we'll hook these up to something at this point. I think we're good. Yeah. So, how do the pads work in the ICAP example we did? So where were the pads connected? Pads. Self. Oh, this one doesn't have a good pad example. Let's just see GPIO. I have Q, we have pads, in pads, length, in pads, and we need to go to something more complex, the USB FIFO. So we have pads, and then pads dot, and it'll give us what we expect. So, okay, let's try that here. we want to do OK pads dot that. All these. And then we're going to do some signals. And these signals are going to be OK clock, OK E, and OK E. And this is going to be one. We'll figure out the lengths of the other one by looking at OK library. The okHOST right here. Ooh, we have additional ones. We should do those ones as well. Well, I guess ignore them for now. So OK clock is 1. That's 113, and that is 65. What a fun length. 113 and 65. We need DNA and DNA valid. DNA. Okay. I don't need day name. I need DNA. 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 Yeah. DNA valid. DNA valid. Okay. And then, yeah. Grab 2 more of these. DNA. DNA valid. I'll probably grab a CSR register to read these at some point, but let's keep it simple. 96 and 1. And 96 and 1. So, there we go. We've connected this. Now we need to create a new instance. And it's going to be an EP wire. So, back here, no, scroll down. Now we're going to do a OK wire in. No, we're going to do OK wire out to the USB system. We can also do an OK wire in and connect that to the LEDs. So let's do that real quick. We're going to do an OK wire in. OK wire in from OK host. May need to pass in these different systems. So we're gonna have OK E and EP address and EP data out. So I just say equals combinational synchronous. We just want to do combinational at a point, right? How do I just like USB FIFO? FIFO depth -4. I think we could just set it as a value. Just say equals this. So how did we do those here? Here in ICAP, we're just doing combinational timer weight equals that. Chaser equals at chaser minus. Yeah. Okay. I think I know what to do. Okay. And then we're gonna have address control. We're gonna make this static for now. Could be dynamic. And we're gonna call it EP address. We're gonna do EP address in. And then we're gonna do EP data out. This is going to be, yeah, we'll just say EP data out for now. Be fine. Boom. Okay, so there's our wire in from the USB interface. So HEU exists, and that's just say okay HE. How does this one run? Okay, looks like it worked. Here that's going to need to be a signal. How wide is it? It is 8 wide. Signal 8, right? I think we need to say self combo, just say combinational, right? And we're just saying, hey, look at this. EP dot they're just doing an equals here. Combinational is a synchronous. Oh, it does say combinational there. So we're gonna do EP dot equals in this situation. What did we do for OKJ tag? We have 0. Wire out is 20. So we're gonna say that is hex, so it's gonna be 32. Um, 0. And then we're gonna do the data, EP data out. Elf.out.storage. We'll have to figure out how to do that, but that'll be something. So maybe we'll just manually do it to the LED. Hopefully it just messes with it. We want to add a reset value that actually no, that will assign it. EP data out is going to be a signal. It's going to be 32. And we're going to put it there. So this should work. So I say, let's build it. Not exactly, we just want to see it work. So we need to add OK pads to here. OK pads, we're going to do an OK platform request. We're going to say okHOST. okHOST. Did my phone go off? Oh, do we have a text? So Titan Boy. This is a brand new, this is a Python description of HDL. This will design HDL. This is going to connect our Verilog files to a RISC-V SoC. That is our goal here. So this is a open source Python-based SoC description that when compiled using MyGen and Litex and MyGen will convert into HDL. We can look at the HDL file. Hopefully this one works. But yeah, let's try. I missed a comma. There we go. Okay, did not like request all of okHOST. How do we request DRAM? Okay, we want to request, just request. Okay, cool. Try that. Wrong format for value DNA. So you are unhappy. Okay, so you're in LEDs. You did not like how we did this instance. Maybe it just does not like uh Okay, wire. Wire. What do you want me to call it? That is what it's called. What if we just ignore that one? Ignore those two. Deal with it later. Okay, yeah, we're getting somewhere. 89, so you don't like that format. You just don't like it where they're the same name, potentially. Okay, let's go back to our interface here. Okay. That should be fine. I guess we could open up, let's open up the ICAP. This has the primitive in here, right? Oh, it's going to be, where's this special? Here we go. We can make it underscore, but clearly there. So I guess we'll go and make them underscores. Very well. Are we not? Oh, let's see. Specials plus. Is there a comma there? Yes, there's a comma. And then everything else. Okay, what do you not like about this? Type name. Okay, let's we're gonna grab this real quick. And what's wrong? So we have self.spam. Well, let's just try this real quick and see if we get past this. To be type name. So do I need to specify different things? Because let's see. Okay, it looks like I need I and O for stuff. What about IOs? Okay, we will try. See what happens. We will say that a look at our library real quick. AA is an in out. So if I say in out, will you be happy? It was happy. Okay, so this is IO as well. Then HU is an out, and this is going to be an in. So this is what you want. Signal is not defined. Okay, cool. Moving on. Okay, HE is not defined. Okay, let's and get this working just fine. So these are outs. And HE is out. This is in. Okay. EP. Oh, you don't like that. So this is going to be input, and this is going to be an output. Okay, beautiful. Let's see if this works, and then we'll trace it. Okay, let's pull up the Vivado file. Or the Verilog file. It's going to be nasty to look at, but I'm curious. So we're going to go Litex, we're going to go to builds, we're going to go to Opal Kelly, we're going to go gateware. The names are too long. We are going to look at this guy right here. And oh yeah, we have okHOST. This looks right. Host. Great. Yeah, look at that. Did we connect that to anything? Yeah, so the chaser, we should be able to change the lights. So if this builds, it works. Crazy. Okay, let's go see where this is going. The wire. And it points straight to the LEDs. Beautiful. So now I'm going to need to plug this board in. I think it powers off of that. So nice. Okay, cool. It connected. So now comes the fun thing of getting the software to work. So let's go figure that out. Why this builds. It's been a while since we've done the okHOST software. I'm pretty sure it's in the downloads folder somewhere. Okay. Oops. When did I get this board? Where is the Python? I'm trying to remember what the Python file I was running here. Okay, here we go. So in this folder, do it by date. Okay. OP, this is the file we probably want to look at. So what we want to do is just set wire in So we want to do that command, dev info, get the dev info, load PLL configuration, and then we want to configure JTAG. Okay, you want all of that in a Python file. So let's create a new one. Save. We're gonna do simple write pi. And what we're gonna do is all this and comment out that file right there. So this shall work just fine with the board plugged in and turned on. So let's try that real quick. Open a PowerShell here. Here. We'll do python.simple write. So return. Okay, exit. Any other returns? Self is not defined. Real quick. Do replace all. There we go. But I define self. FrontPanel support is not available. The default configuration must not have it. Okay, cool. Now we just need to get the bit file, put it here, see if we get anything useful. Okay, how are we doing here? Not place all instances. Okay, let's find the first error and chase it down. May have to open up Bravado to look at this. So we're gonna have to paste this down. You don't have any wonderful constraints like that in your XDC file, do you? No. We'll have to figure out how to add this. Okay, let's grab that real quick. Copy. there's a way to add constraints like that. I guess we could just add custom constraints. I have to figure out, see if there's like a add delay. We'll look at Litex and see if they have an add delay command. But for now, let's make it simple. We're just going to open Vivado right now and see if those things help the build. And if we can get this working quickly, that would be great. Okay. Let's go open a project. Litex, we're in the right directory. You want to go to build, Kelly, gateware, this guy. I have to create a new XDC file or something. Okay, you're happy. So we just want to slap it on here. Well, let's see what constraints they've added. I need to probably go down where the right here the clock constraints are. But yeah, what we're gonna do here, and then that next one. Asynchronous group. We're gonna call that clock. The clocks. I'm gonna see. Okay, where's this clock defined anywhere? That's, we'll just say okay. That's the clock right there. Okay. So let's run synthesis. How long this takes? You may need to specify clock pads. Or let's see, let's go to this guy, right? Let's open synthesize design, go and just see on the okHU or yeah, okHU 0 U0 okay UH0 if there's a buffer we should put there. So it looks like the only one that's requiring any type of blocking. We're running synth design. We're opening design here. It doesn't take long. But we can, trace log files while they run. Okay, almost done. Cool. So, we can see all the signals here. This is the one we want to chase. Those are all going through iBus, except whatever this one's going through. Let's double click that one. Boom, boom, boom. In buff. Cool. Lock in. There is no buffer here. Lockout. That's a buff GC. That's instantiated in the okHI, which is inside U0. So where is ukHI? Cool. So that should be done at the Verilog level. I think we just need to put that constraint in there. We'll see how it goes. But yeah, it looks fine. That is definitely 5, so try this. Okay, here, these ones are going to these registers. So yes, we are looking at the net list. Okay, so looks like 0 should be going through that. Otherwise, I don't think 0 is not going through anything. So yeah, we should be fine. Okay, maybe it's just those constraints. Since this is finished, let's run implementation then. Go for it. So while we're here, I want to see I want to see what did we add to this, right? We are looking for a create clock command. So let's do a Linux real quick. I want to grep rin, what you get from me. I want to say create. Okay. Fine, that's fine. There's something that's not. Okay, so here we are creating constraints. That's still in the build directory. Add platform command. May just need to do those. And copy and paste. Maybe. Might be the easiest. Just platform.add platform command. Well, let's see if implementation works. It messed up in the place stage. Look at that. We got 5, maybe 6 concurrent viewers. Let's see if we got any other fun information. I can look at my monitoring. Doing good so far. Feel free to ask some questions while we do the boring part of just monitoring the build. Okay, it's not happy about this. That's okay. So we're saying, oh, it is MMCO. We do need that. Okay, let us go see if that fixes it. So we're going to say MMCO right there. We want to look and see if we have any MMCO here. Oh, we need MMCO clock. Sorry. MMCO clock 0. Clock. Anything else to pay attention to? So let's, okay, so what we're going to do is we're going to save this. The synthesis is outdated. Synthesis is fine. So what we're going to go is we're going to go to design runs, right click this, say, can't see it. Let's make it full screen. Right click it, say force up to date. Now we're going to rerun implementation. Reset and rerun. And we're going to figure out why it's not happy. We're going to have to follow the signal and see if it did not match this schematic. Yeah, I mean, this schematic's pretty boring, right? Like, oh, but it hasn't placed a buffer. So let's go open implemented. Yeah, sure. Open the implemented design and see if it inserted anything. But so far, I didn't see anything. It went through a iBuff delay type interface, which should be instantiated in HDL. Shouldn't be my responsibility to do that. Yeah, let's go. I'm going to do the XDC file. Compress is true. That's fine. We'll initialize the design. Okay, cool. So design run. What's I'm looking for? PRC. Um, so this is happy with everything. Methodology. Fine. Okay, so it seems happy. Let's pull up the net list. Nets. We're gonna do okay. Four. I don't know. H. UHI buff. Okay, so this guy. This is the guy we want to chase down. So yeah, it's not connected to anything. Going straight to an iBuff instance, which is going to an iBuff control, and going to the MCMM. There's a clock out, a buff GC, and that buff GC is going to everywhere. So this should match. You are not happy. So open synthesize design. Only thing I can think of is if the pin is wrong. Easiest way, right? It's just we're gonna go to PC, and we are looking for this one right here. Should be V23. H0 23 LB must. Okay, that looks like what it should be. We'll figure out. This is different. Why are you doing that? See if I can go scroll up to that. H V22 V23. Ah, found our issue. Okay, so it's an easy fix. So we're gonna go here, V23. Close design. Mistype on the port. Sorry guys. My bad. So we're gonna fix it here, and then we'll fix it over there. But for now, I'm going to grab those. Those are important. So let's go back to design runs. Once again, force this to be up to date because we know better than the software. And then we're going to run implementation, reset and rerun. Okay. Hopefully it should now reference the, unless we saved it. It looks saved. Cool. So let's go back to LEDs right here. We need to add these constraints. I think we should add it here with the platform commands. Okay, so what we're going to do is platform. Yeah, just this right here, right up. Sorry. At the beginning, so platform, add platform, add. We're gonna hit copy. Click there. Oop. Let me do like a flush. We need to figure out how to do curly brackets in a Python string. Google, help me. Curly brackets Python string. Okay, dismiss. Double brackets. Double brackets. If you say so. Double brackets. Double brackets. It is happy. So we're going to take this. We're going to go here. And we're going to boop that there. And curly. Curly. And then here we want that. Yes. Hopefully this works. And because it's bothering me, we're going to line. Oh, it failed again. Okay. We fixed it, right? We said that's on V22. Oh, that one worked. Yeah, that'd be a big issue. Yeah, that one. V23. Is it just unhappy about the slew? I guess we'll open it again and check and maybe have to rerun the synthesis. It doesn't matter, but I don't trust things. Okay. Okay, so it's let's follow the signal. Okay, it's not finding those ports. Why is it not finding those ports? Why is not? Okay, cool. Oh, let me go and fix that real quick. So you won't save it yet. That should be good. Don't save yet. Device view. Now we want to go layout, IO planning. Okay, host. 0 is V23. Could be. Now let's go here and reload. Seemed happier. Okay, let us try again. Running synthesis. How late will we stay up trying to figure this out? Okay, so we were having that issue where we need an OK host for all these ports. Oh, no, so what we're going to do is fix these ones that they're all lined up. Beautiful. I'm going to click here, Control V. That. Hopefully we're happy. And you are unhappy because not finish these off. Okay, now you should be happy. Okay, cool. Background, close design. Okay, blog, synthesis. Got one mistakes. That is fine. I do not care. Ah, there we go. I have a long delay. Must be the encrypted registers. Okay, finish. Let's run implementation. I need to get like a super fast computer for all this stuff. If this FPGA stuff ever, the monetization of this channel ever goes well, we're going to have to do a server or desktop build of the ultimate build environment. What would you need to do? We would want to maybe try to run, or if I get the Fusion IO FPGA card to be a high-speed memory interface, get Vado running off of it. That'd be really interesting. Things to do in the future. Okay, implementation. Good. Anything else? Setting input delay on a clock pin. Okay, okay, let's go read that real quick. That's important. Right here, warning. Setting. Okay, I will go look at my warnings myself. Implementation. Right here. Setting an input delay on relative to clock UHO defined in the same place, not supported, ignoring it. Oh, we did the whole thing. That makes sense. Can you that line real quick? I didn't add that one. Okay. What else we got? Once again, yeah, that command is a good point. Tells me it 6 times apparently. Okay, how do we fix this? Okay, let's open the synthesized design. I guess we gotta trace this down. So what are you doing in this situation? We want the, let's go layout. Oh, layout. Our layout. It's not working. I guess we can just go to the okHOST, go to the nets here, grab this one. Oh, so fancy. Add. That is where we want to start. Teach me what you're doing that's wrong. Okay. We have an input buffer. I don't want an input buffer here. I guess no, that's fine. Okay. What I'm seeing is this now, which is fine because it's all inside the okHOST. That looks fine. So messages, errors. Okay, so it's saying high clock buff G and OMC is previously placed by clock placer MMCXYO. The above error related to other connected instance following is a list of all the rules and their respect. Only one of in a pair can be used at the same time. Placed by clock placer and X01. Only one of the available sites in a pair can be used at the same time. Hey, wait a minute. Where is the system clock coming from here? Right. Yeah, it's completely different. Okay, what is the issue? Oh. Sure, that seems fine. Right, so if we go to schematic, do clock out 1, that's the buff GECE right there it's talking about. We pop over here, schematic, right? Buff GC. Seems fine. I got no issues. Now, what else can you tell me? So we have an iBuff. So I think we have to see we're going to highlight this sucker. Red. Oh, here, no, device. See, it's that one right there in the XO provisionally being placed. Okay, nets. What's happening here? So we're saying that the other one is being placed there as well. So, are we even grabbing the other clock? E24. That's this clock. Yeah, sure. F4. Different output. Yeah. Looks good. Buff GC. Cancel. We want to highlight this as red and highlight this as red. So let's see. Even see where those things are. So maybe we're just using too many MMCMs here. What's the best way to fix this? So if I had to guess, make an educated guess, if we go to target here, we have this really weird buff GC buff here, which we normally don't see in other systems. And I don't like how that's being done. So let's go look at, I want to do how this one's doing it. And that's what we're going to do. Instead of this. CD, CD4. So go like that. This right here, actually, this right here is what I blame. Okay. Save that. Okay, let's go back to Litex builds. That one. Opal Kelly XDC file. I want to know what he's did we not fix it? Fix it. Excuse me, I need to go fix something before you get too far. Let's double check here. HVV23. Okay, so we double click this, it'll highlight that one, which is very wrong. And then it's V23 now. It's great. Where are these other fun constraints that we've added? I think that should be good. Worry about the timing issue later. Oh, okay, no, I think we should be able to do that name. So go ahead and add that. I'm not going to find it until later. Why did it fail? Read it. I didn't change it. Okay. Um, where's this register? Find. You were happy about this before I took this away. It's the reset. Where should we go? What's our current frequency? 125. Let's just make this 100 right now. Good. And yeah, that's fine. So you don't like the reset. Sure. I'll take that. Oh no, wrong category. This guy. Oh, that's probably what's unhappy. I wanted a raw reset signal that we don't have. Huh. Okay. Maybe. I don't know. Maybe it's read in correctly. Okay. Let us see how it goes. I believe the XDC file worked. At least it looks like it worked. Oh, we're going to add the getting kind of late. Hopefully this works. Excited. So, but maybe we should explain a little bit what I was concerned about. So if we go back to this target, it was using an additional buff divide and a buff GC. And if we remember, the command was the main buff GC was not working. And from what what I could think of is that we were just doing too many. And I don't know why it would do that. Maybe it was couldn't get like a good thing going. We'll see how this goes. we may have just, introduced a new problem. See if we can go look at those warnings. Okay, it's just the same pin thing. I wonder how they were doing their buff GC. Good question. We're going into the placer. That's good news. That table. Where's my JTAG cable? The JTAG. Oh, we had an error. And it failed. So all I can think of is that we have too many clocks. So we have the okHOST buff G. Get a buff GC right here. What's the rule? But what signals are we dealing with that are an issue? What to do? So currently these two are the same. So what if we do that right there? And we're just gonna add these two there first. That there. Reducing wasted. Reducing resource. I think I misplaced something. Close it up. This. That. If not, we'll just take out the HDMI port. Just move that out. It's a good question of how do we resolve this, right? So we have all of our clocks pointing to the same thing. We're pointing to the same fabric. We could use the output of this guy. Some things. They're just on the same bank. So that's 4x, right? With 125, which is going to be 500, which we're using for our eye delay control. Is that not sure what this submodule is actually doing. I guess it's just using that clock for the references, essentially. Whatever's happening. Okay. We're down to the optimizations. Change that to this. Or it's just clock frequency times 4. Fine. Debug by the point. Here's the IO placement, clock placement. So we'll see. I bet it's just using 2 of the MMCMs that was breaking it up. No, you're still unhappy. Okay. There's too many buff GCEs. Probably just the type of buffers they have for this. Okay, so we get one more try. That one more try is no video. We'll have to play around with how this works. Okay, cool. I think we got everything. We can scroll up real quick and just make sure that we only have those two clocks. And we need to figure out what type of buffer. Maybe just a buff G, because it's automatically doing a buff GCE. Right, so it maybe we need to do different buffers. This automatic buffer thing is killing it. Well, let's go here, right? Let's zoom in on these different buffers and understand the site. This is a buff GC. The buff GCE, and this is a buff E. Let's find edit, find primitive is what buffer, IO bidirectional block buffers. Yeah. So let's see what we got. So you are using, okay, show me how many we have here, right? Let's mark them all green. They're all the buff G. Zoom out. So you are using two buff GC there and your instance. So you have 3 by yourself. Buff GC, we're using a PLL here. And then we have advanced one down here and a bunch of, that's for the DDR interface. And this is for also the memory interface. Okay, so it's using all these, and that's still, let's see. Okay, right here. 1, 2, 3, 4, 5, 6, 7. Where's this one? Over there. Okay, so 1, 2, 3, 4. 1, 2, so 6. And we would have been at 7. Hopefully that works. And then we have to refigure out our system. Let's look at this real quick. I want to look at ultra scale primitives, please. What are the clock primitives that we have? Can I specify a different primitive than that default one? Or maybe just use an MMCM in a different category? Good question. Okay. Here's my buffer. Okay, so we've been using the buff C, Okay, so these are just wrappers around each other. Nothing terribly special. There are a different buffer. Um, you just have to do local buffers. Or maybe you have to do buff GC divide. With a divide function. Unless these already have it. I want like a normal clock and really? Okay. You saying you're having too many. Let's go open your synthesized design. First, you have to synthesize you again because I guess we opened a DCP. There's synthesized DCP? Question. Um, let's see. Is there a checkpoint? That was an old one. So let's go ahead and open this and run synthesis and just see how many buff GCs they are expecting. Okay. Okay, so starting here with buff GCE, buff GCE, buff GCE. And which one is this placed to? It's placed to XM1. Oh, it's placed there. Maybe there's another MMC and we're not missing. Run synthesis real quick. Okay, so back here. Provisionally placed on Y2. We don't like that. I agree. I can see how that's an issue. Why is it placed there? Okay, explain to me why you are going there. We're not specifying any routing, are we? That would be in the XDC file. Let me look if we can open it up here. We have any placement constraints? I doubt it. Nothing there. How many MMCMs? We only have two. Only two. How many buff? I don't see why it's to be having an issue. Okay. Do advance is placed there. Why is it being placed there? Why can't you be placed in the What is wrong with the placer? You have to just run op design and place design. Slice. So yeah, I don't know why it's being placed up here. Find out. 2 instances and 6 instances. Okay, that's what I forecasted. Clock is C24. Background that. C24. Makes sense. Yeah, I got no clue why you would be placed otherwise. You got 3 there. I'm not telling you where to place. Why are you? I agree. Why are we doing that? Edit, find all instances. So let's do op design. Fine. Hmm. Okay. Has been place design. So we're going to place design real quick. And I need help understanding why you're going crazy. Yeah, why are you doing that? I don't understand. IOB XY37 must. Okay, so if we go here, right? F4, right? iBuff control. What is this? That's not the one I want. I want this guy. I'm gonna do what? Clock in. So what are we saying here? Okay. Thanks. Subscribing, Steve. Trying to figure out why this instance is not working. XOY73. Okay, which instance is that? That is the iBuff control instance. XOY60. Properties. Okay, XOY73, Y73. Okay. What is being placed? That's good. That's fine. You can see where these ones were placed, right? So which one is this? This is the FBVG. So this one right here. This one is placed on 36. Why is this being placed there? Okay. Go back to find results. Rerun. I want to place this for planning. How do I manually place this? Because you're annoying the snot out of me of why you would do such a stupid thing. Okay, right here. Ah, why is this so confusing? We try to build this on my side. Different. Maybe it's all the eye delay control, maybe? This says please insert a butt G. Okay, let's see what this one here. Place in for a clock. G. D E. This is so what? Okay. Give me the source. If we look at this, what what are you doing with your MMCMs? Okay, let's go back to find results. Here, properties. Why? Okay, I will do one more thing. And then we're going to call it a night. We're going to go here, and we are going to ignore the UART. I don't even know what this we build about a UART. Will you build without a UART? Guess we could just do some UART pins, right? So, okay, let's look at another board. Should be already. Let's grab the UART. Oh, okay, so it's just serial real quick. Go back here. Um, Go like that. We're just gonna grab two of the AC 14 and 13. 14, 13, and we'll call it good. Nothing I can think of at the moment. Otherwise, what in the world? Okay, so let us just download that file real quick. I'm gonna go to Litex. I'm gonna go to Litex. Build here. Gateway. So we're gonna grab two things. We're gonna grab these two files. I'm going to download them. Sure, we'll download them there. I'm going to, we're gonna have to, going to close out this real quick. So, hierarchy, we're going to add source. Design source, add files. I'm going to go Litex. Yep. While you're thinking, okay, we're gonna add source, Constraint, add file, finish. We're gonna set this as, and we are going to disable the other one, disable file. And then we are going to do this one as top. And run it all. Sounds good. And we're just going to say run implementation. Oh. Okay, sure. I'll have to do a new project. Try to see how quick I can do this. This is the part I am looking for. Yep, 0. Okay, cool. Do not specify at this time what I want to use. Finish. Actually, let's go back real quick. I can specify all my files. Data file. For Litex, we want to add this file. We're going to add a directory. It's going to be program files, Kelly FrontPanel, yo. I wonder if it's a different Vivado version. Maybe issue. Be cool. Add a file. Okay. Next. Finish. Yes, we'll close. Oh, okay. I'm gonna be unhappy about that, but I can fix that quickly here. Wait a minute. Which Pmon are you AP1, 3. We want to do PMod 4. Okay, let's do AD instead of AC. AD, right. Yeah, it should work. Okay, cool. Let's go to constraint real quick. Define serial is going to be 33, 3, 80. Okay. Run. Go. Be free. This is a fun problem. Oh, I need that file. I'm gonna be unhappy. Okay, so going down that file. Be Python data CPU vectors 5. Okay, Python data vectors 5, vectors 5, Verilog, vectors 5. This guy right here. So we're gonna download him into the same folder. And here, since this failed, vectors 5 not found. That's fine. We're gonna add source. Okay. Vectors 5. Finish. Dating. Rerun. What would be best? Hmm. So you're working there. Finish it soon. Okay, this is probably the last. This we're gonna end tonight. This is I'm dumbfounded after this of what could possibly fix this issue. Because I would assume it's just routing it wrong. We could try getting the correct version, but I don't think that should be an issue. So like the HDL files could have a potentially a different version. Yeah, I mean at the point where I think it's either something critically wrong in the system. Okay, I had the same errors here. So still placing it in these random places. I don't know why you're placing it there. I agree with that location. I don't know why you didn't do the X1 location or the Y1, the X0 Y1 location. I guess I could try to manually place the sucker. Why? That's my only question. Okay. Any warning, anything that would be useful? No, that's fine. Because we're not using the clock? That it's upset about that. Okay, let's go find that okJTAG file. May just be upset that we're not using it. Like it's affecting sources. Okay, let's look at this guy. Okay, that's fine. Where is this okay clock being used? On it first. 3 matches. Yeah, never being used whatsoever, so not an issue. We're doing the croc clothing here. That's a little bit of an issue. I know, and this does the croc clothing for you. How nice. I have to remember how that just works. Otherwise, we should be fine. Okay. Um, let's go back here. This was writing synthesis reports. Sure, I guess that's okay. Okay. Okay, here we go. This is where it fails. Now, why? Will it run? Will it not run? Let's figure out. We do. Let's look at the tickle they have over here real quick. Litex boards. Opal Kelly. Tickle. You doing anything special here? Yeah, nothing out of the ordinary. Okay. Um, Typically, when do you fail? In the stage, we will let it think. I wonder what's different. Thinking is different. They have more high delay controls. I think those are on all the interfaces. It's not a big issue. Hey, you're still thinking? I don't even know where to push this air. This is a weird air. I mean, what else could we do is go to the XMA0 and put a pin out. And I right there. I do not know what else would be useful. Sure, that makes sense. I guess we can just do that for the net and try to rerun it. Maybe that just fixes everything. Okay, let's see. Is the output for both the OK library and the source big? Okay, so that property, I guess. It fails. It fail. So hey, it didn't place the other one bad. Main CRG clock in. Okay, so do this. Go to the XTC file and slap it on the end, I guess. Right here. But we want to do main CRG clock in. And go here, of course, up to date, and run implementation, reset, and rerun. Okay, and if we add that to the LED, something like that, you know. Changes this. This doesn't have the first error though, so this is definitely placing it differently. I'll have to make a list of things to try. Important. So first thing to try is just creating the project the same way we created this project with Vivato 2022.1. Reference the same files. See if that fixes. Guess that's really the only way. Try the new files. Oh, passed it with flying colors. That's crazy. Okay, so that was a fun issue. See if that fixes it here. Okay, so currently routing. I guess we could, yeah, generate this bit file just fine. Taking too much longer. Let's see if this one works. Go to the synthesis stage. Probably want to do JTAG phi again. Slowly introduce everything else that we did. Routing is done. Cool. We'll generate a bit file soon for that. How about you? We finished synth design. Good time frame. Check you in a second. Okay. Generate bit stream. Ah, this is running just fine. I hate you all. Okay, so apparently when the issue they provided their system clock on the same pin. Oh, so annoying. Oh, look at it go. Since we're already building it in one location, let's I want to get the JTAG file working. So be gone. Go over here with my JTAG file. Come back. And now build. You work on that. I go here and generate bitstream. Oh, look it's the next day already. We'll do this quickly. So best way to say is that I hate this. That's the best way to say this. Is that the main clock port? I need another clocks. Okay, let's find a different clock. Documentation. Tell me the clocks because I hate the clock you're using. We could use an MGT clock. I like that idea. We'll have to do a clock divide. Do an MGT clock. So whatever. This clock is stupid. It's on the same bank as the USB one, and when they try to share, it just hates life. Should see if there's okay, let's look for something real quick. Instead of using an MCM, let's see if we can use the PLL. That'd probably solve a lot of things. So what we want to do, so here we're using one of these. And I need to find out where this is defined. Probably defined in the MyGen area. Submodules PLL. Okay, let's go find it. Sure. Here, cd Litex. Here first, I guess. Grep dash. When you want a US and then CM. I saw a useful thing. We just get above the timing report. Okay, so 4 clocks. Let's see what we got. To do Litex, get out of the build directory. We want SOC clock. Go to Xilinx Ultra Scale. USPLL. Okay, so let's see if anyone's used the USPLL. USPLL. Anyone using it effectively? I do not see. So let's go to Litex boards and here. Nope, no one is using this interface. We have clock frequency. So what's this inheriting from? Xilinx clocking. That's coming from Xilinx common. Okay. Guess we could try to make it a PLL. So there's a PLL on the same bank that would prove more useful. Okay, this is going to the build, so it's routing already. Okay, cool. Remind me later. So let's go back here. I want to figure out if you are happy with me if I go into, where is, not what I want to do. Here, I want to comment out this command, and I want to go here, and our CRG, I want to do a PLL. And since these commands are kind of the same, let us try this. They should have used a PLL instead of MMCM somewhere. Okay, let's export bitstream file. We want to export this to downloads. Yeah, whatever. We are going for that guy right there. And we're going to call him Litex.bit. Okay, cool. We're going to go here. We do simple write. We go Litex.bit. And do this. Panel support is available. Now we need to write a wire. So let's go find our good old wire friend, right? That wire in here. And we are going to go 0. And we're going to go, since there's what, 6 LEDs, be able to do that. If it's not defined, you are correct. Didn't see anything change. Oh, do I need a... okay. Update wire in. That's right. There's a beautiful update command. Forgot. It worked. I can't show you this, but it worked. It worked. It worked. It worked. It worked, guys. Got Litex working with Opal Kelly. It's possible. We're gonna go crazy. Ah. So I'm gonna let that build. I'm going to bed. Good night. Good night. This was a success. We will explore doing a UART over this with the FIFO system next week. R2, hey, give me a second. I just want to see if using the PLL changed anything. Actually, let's go the primitives on here. I want to see what the PLL is. MC, okay, advance. Clock out 0, clock out 1. So we only have 2 clock outs. Can't do anything else. What is inverted? So maybe we could do 2 different PLLs. Okay, MMCM on another one. Might be able to do that. Pass it off. The buffers are fine, so we probably can return to using that method if needed. We design completed successfully. Okay, let's see if we get through the play state. This is the thing that broke us. This time we're using a PLL instead of a MMCM. Okay, I believe. Okay, I want to go back to Python, add extractive terminal info. Right here. What we're going to do here is we're going to provide an interactive shell at the end. Okay, and we need that terminal add tab. I guess we shall. I read line. Okay. Now save it. Pip. Right. Pip install pyread. Pyread. Okay. Okay. Python shell. June 24th. I want something older. So June 9th. Run Python terminal after script. So yeah, I'll go through my history on my other thing. Add. Okay, let's see. The other useful stuff. Oh, we want Python. There was a way to do it. How did I do it? Uh, so I'm gonna say June 9th. June 9th, I'm going to find let's make the dates. Give it a range. FPGA beginners. A good question. Where do you want to begin with? Where would be the best? I'll have to look into figuring out a good way to do that. Okay. I'll think about that. I'll look at some books and try to get some good options. Okay, so we want Python tab completion and interact in shell. Oh, we should say autocomplete. Autocomplete. That's true. We could do a Python thing. I guess we'll do that. But... doesn't like that. That's okay. So we have an interactive terminal. We'll just have to get IPython working here. So if we do XM, right, we have that. We want to do XM. That wire in value 0x00 0x00. Okay, cool. We're going to do XEM update wire and do XEM.h there and there as well. I'm sorry, I don't have that up. Okay, cool. Here we ran into an error again. Okay, it didn't like that. Cool. Well, we're gonna try some other stuff later. Good night. Hopefully we can figure out. I'll get an IPython shell working and we can see things up and running. I spent too much time online. I'll look at some FPGA beginner stuff, but try our FPGA. They have a great source of things. And they can help you out. So go to Reddit, rFPGA, and you'll r/FPGA, or the FPGA subreddit is probably a good place. They got a pinned. Actually, I'll just show you that real quick. For new FPGA people, let's just go to here. And useful links for beginners and veterans. Cool. Copy this link. Can I add it? I can't put it in the chat. But here you go. List of useful links for beginners and veterans.